Hi guys, so today we're going to go through kind of the next part of our notes on trig functions. So the page in your notes says trigonometric functions, so you can go ahead there. All right, so in Math 2 and Math 3, you focused on three different trig functions, which are sine, cosine, and tangent. You also probably, and we practiced with this before, have heard of something called SOHCAHTOA. And that gives us the relationships for sine, cosine, and tangent. So you know that sine of theta is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So now we're going to talk about the other three, which are cosecant, secant, and cotangent. Cosecant is the reciprocal of sine, meaning it's hypotenuse over opposite. And I remember that with the C goes with the S and the C goes with the S. So they're kind of opposites. Cosine goes with secant. So hypotenuse over adjacent, it's that reciprocal. And then cotangent is the reciprocal of tangent. So adjacent over opposite. So another way that you could think about this is cosecant is 1 over sine of theta. Secant is 1 over cosine theta, and cotangent is 1 over tangent of theta. And these relationships work the same as the three that you've learned about previously. So I'm going to do a few examples with this. Starting on number 1, we're looking at angle theta. So this is opposite, this is adjacent, and this is hypotenuse. So sine of theta would be 12 over 13, opposite over hypotenuse, which means cosecant is 13 over 12. Cosine of theta would be 5 over 13, which makes secant 13 over 5. Okay, and then tangent of theta opposite over adjacent, and then adjacent over opposite. Okay. All right, then let's actually go to number 4 because I want to do one with a square root. Now in this one, notice it's a right triangle and I only have two sides given to me. You may remember this relationship is actually a 30, 60, 90, but let's just do Pythagorean theorem in case you don't remember those relationships. All right, so a squared plus b squared equals c squared. So this is 36 plus 36 times 3, which is 108, equals x squared. So 108 plus 36 is 144. So that makes our hypotenuse 12. All right, so this is opposite, this is the hypotenuse, and this is the adjacent. So first we have opposite over hypotenuse. So that's 6 square root 3 over, not square root 13, square root 3 over 12. That does simplify to square root of 3 over 2. All right, I'm going to go through now cosine. Cosine would be 6 over 12, adjacent over hypotenuse, which is 1/2. And then tangent opposite over adjacent, 6 square root 3 over 6 is just square root 3. Then for the reciprocal, so that's 12 over 6 square root 3, which gives me 2 over square root 3. Remember, we don't want square roots in our denominator. So to rationalize this, I'm going to multiply by square root of 3 on the top and the bottom. And I get 2 square root 3, and square root 3 times square root 3 is 3. This one would just be 2 because it would be 12 over 6. And then this one, 6 over 6 square root 3 gives me 1 over square root 3. But again, we don't want square roots in our denominator. So to rationalize this, we multiply by square root of 3 on the top and the bottom. So that gives me square root of 3 over 3. All right, so then in the next section, it gives us a fraction. So let's do a couple of these. So tangent of theta, we have to draw the triangle ourselves. It doesn't matter where you place theta, okay? We know that this is opposite over adjacent. So that means opposite is 7, adjacent is 24. Then we'll have to use Pythagorean theorem to get the hypotenuse, and that ends up being 25. All right, from there, we can just fill out just like normal. We just had to draw the triangle ourselves in this one. So here we have sine is 7 over 25. which makes this 25 over 7. Cosine is 24 over 25. 7 over 25, 24 over 25, which makes secant 25 over 24. Tangent is 7 over 24. Notice that was given to you, which makes this 24 over 7. All right, let's also do number 8. So secant, remember, is the reciprocal of cosine. So instead of being adjacent over hypotenuse, this means hypotenuse over adjacent equals 4. Okay, so we're going to draw our triangle, put in our theta. So this means I can also think about this as 4 over 1. So that makes the hypotenuse 4 and the adjacent 1. I am going to have to use Pythagorean theorem for this. And I just went ahead and did 4 squared is 16. So x squared equals square root of 15. All right, so then sine of theta, opposite over hypotenuse, which makes this 4 over square root of 15. But we rationalize, so we get 4 square root 15 over 15. Cosine is adjacent over hypotenuse, so that's 1/4, which should be the reciprocal of secant, and that's 4. And then tangent, opposite over adjacent, that's just square root of 15, and then 1 over square root of 15. When I rationalize, I get square root of 15 over 15. Okay, so again, exact same as what you've done with sine, cosine, and tangent, but this time we're introducing the reciprocal functions. All right, these are your 30, 60, 90 triangles. So I'm going to go ahead and kind of fill in the bottom of these. That is kind of the introduction to your unit circle. So we have 1/2 square root of 3 over 2. I'm just going to fill these in and then I'll talk about them a little bit. So if we look at, I'm actually going to start with the 45, 45, 90. That's isosceles, which means my two legs are congruent to each other. The relationship there is the two legs are congruent, and the hypotenuse, if we think about x squared plus x squared equals my hypotenuse, which is c squared. So that's 2x squared equals my hypotenuse squared, okay? If you were to take the square root of both sides to solve for c, we know the square root of x squared is x, and then we're left with square root of 2, okay? So I'm just going to show you like one of these, what it looks like. So if we were going to take the sine of this angle right here that I just circled, opposite over hypotenuse, so x over x squared root 2, we get 1 over square root 2, which I can rationalize to get square root of 2 over 2. And that's where this part comes from. When you get to your unit circle, you'll have a lot of these memorized, or you should have a lot of these memorized. So it's not something necessarily to stress to memorize these, because you'll be able to derive them from your unit circle. You heard me mention back here that this was a 30, 60, 90 triangle. So the short leg, which is right here, is always x, which is across from your, where'd it go? Which is across from whatever your 30-degree angle is. And then the other leg is x square root 3, and then this one is 2x, okay? So let's just again look at one of these for 30 degrees. If we're looking at the 30 degrees, sine is opposite, which is x, over hypotenuse, which is 2x. So that gives me 1/2. If we did the same, if we did sine for 60 degrees, which is up here, opposite is x squared root 3, hypotenuse is 2x, and that's how we get this square root 3 over 2. Okay, because remember, those special relationships exist for those special right triangles. All right, flip the page. We'll do a little bit more practice with all of these. Okay. Now, if we have a kind of circle here, remember we have the formula for a circle, x squared plus y squared equals r squared, and that's if it's at the origin. Okay. So in this case, you can kind of see this triangle here that we have r is the hypotenuse, we have x is the horizontal length, and y is the vertical. So we're just going to kind of do the same thing here. Sine is opposite over hypotenuse, which is my radius. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. That is a y. And then these are just the reciprocals. Okay, so let's do a few examples. Let's start on number 1. It's going to give you a point. So first thing to do is just sketch it out. It says 9, negative 12. So that means you're going to be down in quadrant 4. This is 9 and this is negative 12. And that makes sense because right here we're going right and we're going down. We do need to use Pythagorean theorem to find our hypotenuse. And that ends up being 15. From there, it's the exact same thing you just did. Just like we did in the previous ones, it's just now our quadrants. We have to take into account the negatives here. So sine is opposite over hypotenuse. Adjacent over hypotenuse. This is my opposite. Theta is always the angle towards the origin. I should clarify that. So this is angle theta right there. Always, every single time. If it were in quadrant 1, it would be right here. Quadrant 2, that angle there. Quadrant 3, and quadrant 4. All right, tangent of theta, opposite over adjacent. And I'll go back and simplify these in a second. And then cotangent is 9 over negative 12. All right, so if I divide top and bottom by 3, I get negative 4/5. I get 3/5. I get negative 4/3, negative 3/4, 5/3, and negative 5/4. So notice in quadrant 4, this is a big idea. Sine is negative because that deals with the y value. Same with tangent. Okay, cosine though is still positive, okay, in quadrant 4, because that just takes into account the x value. And then tangent is basically, and we'll get here, but it's sine over cosine. So if one of those is negative and the other one positive, tangent will be negative. All right, so that brings us to the signs of trig functions. So right here we know if I have a coordinate, it's going to be positive, positive. Negative, positive, because you went left and up, negative, negative, and positive, negative. Okay? All right, so in quadrant 1, if we're thinking about everything is positive, so that's sine, cosine, tangent, cosecant, secant, cotangent. Everything's positive. They use the phrase all students take calculus to remember what's positive. So in quadrant 1, everything's positive. This one, sine will be positive, and it's reciprocal, which is cosecant, because the sine is the y value, and that's positive there. In quadrant 3, tangent and cotangent are positive, okay? Because if you think about, in that case, two negatives, you're dividing them. Negative divided by negative is a positive. And then in quadrant 4, cosine, because that's the x, and the x you're moving right, is still positive and it's reciprocal. All right, so it tells us in number 3, if cosine of theta is greater than 0, meaning cosine of theta is positive, which quadrants could the terminal side of theta lie? So where could the angle be? It could be in quadrant 1, because everything is positive in quadrant 1, or it could be in quadrant 4, because cosine is also positive there. Then it says if secant of theta is negative, meaning it's less than 0, where could it lie? Well, that secant is positive the same place as cosine is positive, because it's just the reciprocal. So it's going to be the opposite of the question we just said. It could be 2 or 3, because here and here, my x value, my cosine will be negative. All right, and we're going to do one more example here. All right, so in number 7, sine of theta is 8/17, and tangent is negative. So that means sine is positive. Sine is positive here and here, and this is how I would recommend you do it. So sine is positive in quadrant 1 and quadrant 2, but tangent is negative, okay? Well, tangent is negative here and here, quadrants 2 and 4. Well, we need both those statements to be true, so that means that that's going to happen in quadrant 2. Because quadrant 1 doesn't work because tangent's positive, quadrant 4 doesn't work because sine is negative. And it tells us sine is 8/17. Remember, that's opposite over hypotenuse. Theta is always the angle towards the origin. So this is opposite hypotenuse. We will have to use Pythagorean theorem. Okay, we end up getting x is 15. Now, when I go to label this, I'm going to label that as -15 because that is going left on the x-axis. So if you're doing Pythagorean theorem quickly, make sure that you label if you're going left, it's negative, or if you're going down. So then cosine -15/17, tangent -8/15, okay, opposite over adjacent. Cosecant is the reciprocal of sine, so 17/8. Secant is the reciprocal of cosine, so -17/15. And cotangent is the reciprocal of tangent, so 15/-8. All right, so that kind of leaves you with a lot of this is just some Pythagorean theorem, some trig, and we're just introducing those reciprocal functions. So make sure to also watch the video on unit circle, which will go through kind of that, and then you'll have a chance to practice with all of this. Hope you have a great rest of your day.